Hey guys, so today we are getting back into our journey for circles. Now, if I remember correctly, at least towards the end of looking at circles, things got a little bit complicated for many of you, and so we're going to start it off again like we have been reviewing everything from the beginning again. Now, the reason I'm going into circles is because we have tackled the three-dimensional shapes, the polygons, all of those. Logically, we go on to the next type of shape, with the little break of truth tables in between with circles. Now, circles are a little bit different in terms of the normal polygons we've seen before, because with normal polygons, we don't really have a formula for them. Circles have a formula. That formula is x minus h squared plus y minus k squared, which is equal to r squared. Now, we have a formula for circles, we don't have a formula for regular polygons. That's because with the regular polygons, we have lines. So if we have a triangle is made up of lines. A square is made up of lines, and so on and so forth. So when we put these on a graph, we don't necessarily need a formula for the specific shape. We need a formula to get those lines, which we already have. That's why we end up with the line formula of y equals mx plus b. Now, I mentioned that circles are different because they have a different formula, so we need a way that given a graph, we were able to pick some point and around that point make a circle. So we need two main parts of our circle in order to do that. We need our starting point, our center point, which in this case is going to hold the values of h and k as the x and y value for our center coordinates. Then we also need how large our circle is. Now, there are a couple of ways we can do this. The most commonly and always necessary for a circle is the radius. Now, I mentioned there are multiple ways because if given, say, a diameter of a circle, we could still get the same kind of formula from the diameter, except it's much more commonly used with radius. So radius, of course, as always, is just set as r, and right there we have everything we need for our circle. So when actually given a specific center and a specific radius, I believe in these slides I end up using a center point that is -5 and 8, and a radius of 3. Well, in this case, we have all the information that we need, and we just plug in. So we know that we take a look at the values we're missing. So x and y are just everything we're going to plot on the actual graph itself. But h, k, and r are values we need to input ourselves in order to actually create our circle. So if we take a look, we need h, we need k, and we need r. And so in this case, when we take a look, our h value comes from the x value of the center, so that would be -5. Our k value comes from the y for the center point, which is 8, and our r is the radius, which is 3. Now, of course, if you were given the diameter, you would just take half of the diameter in order to get the radius. And at that point, then, we just plug into our formula, where we end up with x minus a -5, and this whole thing is squared. You add together your y minus the k, which is just 8 squared, and this is equal to your radius squared. At this point then, there's some minor simplification that you could do, but this is more or less done. The minor simplification is taking this minus -5. When you subtract the negative number, it becomes positive. So that is just x plus 5 squared. The y minus 8 squares stay the same. And then you have 3 squared, which when we do that becomes 9. Now just to take a quick look at what kind of happens when you do that. So this is a little bit of that extra talk that I had in the slides, but ultimately I am going to do some approximation more so than exact points. But on our graph, we end up with a value of -5 somewhere along our x-axis here and an 8 along our y-axis here. So this will end up as our center point for the circle. Then, as we check our radius, well, we'd go 3 spaces to the right, and then that would be just about -2. So 3 spaces to the right, and that is our first point for our circle. So if you plug in x as -2, you would end up getting y still as 8. Then continuing on from there, once you solve for y, that is. And so this just continues that for all of these values between where you actually have your graph, this would be another movement of 3 over to the left, which would give you the a -8. And so between the x values of -2 and -8, you would end up slowly getting the entire circle around that number. And that's what these x and y values are. Now, this is just the start of our circles. We're going to start looking into them a little bit more in depth. But for now, just to understand that our formula is as follows, that whenever plugging in for these, you need to have a center point and you need to have a radius. You may be asked in different ways to find this center point. Sometimes you may be asked to find the midpoint of a certain line segment. That is your center. Sometimes a radius is seen as a diameter. But ultimately, as long as you have the center point and the radius, you just plug into this formula here and you are set. There is one main point in which this actually becomes very important, and that is the difference between your original circles and every other circle you can create. So it's just remember that, let's say our center point is just 0. So we're going to restart all of this, and it doesn't really matter what our radius is. Let's just say that our radius is 10, right? So if our center point is 0, if we plug into this equation, well, what happens with our h and k? If our h and k is 0 and our radius is 10, when we plug into this equation, we end up taking, and this is technically the longer form, that we have x minus 0 squared plus y minus 0 squared is equal to 10 squared. Now, when you subtract 0 from anything, nothing happens, so we could just drop that x and that squared, because that's all that it is there. Plus, and the same thing happens with y. Y minus 0 is just y, so why even have that minus 0 there? Leave it as such, and then the radius is the only thing that really matters, making this circle. And this is the circle that, along your grid, is put at the center of the crosshairs. So the size of the circle itself is based off the radius, and so you could have multiple sizes coming from the center point, whether slightly large, slightly smaller, and so on and so forth. Every other circle will have a specific x and y value that you have to plug in for, but whenever it is at the origin point or 0, 0, that is just x squared plus y squared, and then you have the radius squared on the end. Hopefully this is coming together. We're starting off a little bit slow here, but as we continue forward, a lot of the information will stack up on top of each other, and so try to keep with these, make sure to ask questions as necessary, and I hope you are enjoying your day. Stay safe and healthy.